optimisation questions are usually quite big questions and make up quite a lot of your marks. They're normally split up into at least a part A and a part B. So part A is always worth slightly less, and it does involve a little bit of problem solving. This is the type of question that you would have to practice, you would have to work on, and the more you see of it, the more familiar you'll become with it, and the more confident you'll become as well. Part B is a lot nicer because it is something that we're a lot more familiar with. So this question would form part A. So it gives you some information about a shape, and what's quite nice about your optimisation questions is that most of the time they will tell you what you're trying to get to. So in this case, they want us to show that the area of the glass case is this. Now you need to use all the information that they're giving you to show that. Okay, so if we start off, there are two things that are really mentioned in this. So it mentions the volume and it mentions area. So we're going to have to work with both the formulas, which you should know from years ago, back when you first learnt them in S1 or S2. So the volume of that square base glass display case is going to be length times breadth times height. Now we know that our volume is 500 centimetres cubed. We're given that in the question. Our length is x. Our breadth is also x. And we're not actually given anything for the height, so we're just going to call this h. So we're timesing it by h. So that can be simplified to 500 equals x squared h. So right now, that's as far as we can go with that. So we're going to have to stop there. We can now look at the area. So the area of this, we're looking for surface area. So we need to find the area of this front part here. We need to find the area of the sides, the area of the back, the area of this other side. Now with these questions, always make sure you go back and double check if there's any additional information given. So it's saying here that the base is not made of glass. So for this one, we only then need to find the area of the top. We don't need to find the area of the base. So we're going to find the area of this front here. So for the area of that front, it's going to be x times by h. So length times by breadth or height. So it's going to be xh. However, we know that the back is going to be the same as the front. They must be equal. So we've actually got two of the xh's. We can then do the sides. So our side part here is going to be x times by h. But remember, we've got two sides. So we've got another 2xh. And we can then find the area of the top. So it's a square based. So the top's going to be square as well. So it's just going to be x times x. So x squared. Now that can be simplified because if we've got a 2xh and a 2xh altogether, we've got 4xh's and we've got this x squared. Now, if you look at these two things, the only thing that doesn't form part of what we're looking for is this h here and this h here. So we now need to try and get rid of this h. Now, given that we want A equals something, which is what we've got here, we're going to manipulate this volume formula to help us find a value for h. So if we've got 500 equals x squared h, we can divide both sides by x squared to get h equals 500 over x squared. So that then gives us a value for h. So we can then substitute that in to that part there. And when that happens, we'll be getting rid of the h and we'll be introducing more x's into that formula. So we've now got a equals 4x, but we're going to times it by 500 over x squared, which is our value for h, and then we're adding on an x squared. If we work through that, we get 2,000. Now we're going to have an x on the top, is going to cancel with one of our x's from the bottom. So we're going to have 2,000 over x plus x squared. Now, if you compare that back to what we were looking to get, the only difference is they've got x squared plus 2000 over x, I've got 2000x over x squared. Either way, they are the exact same, just written in a different order. So I can just finish off by writing as required. So that's me found exactly what they wanted me to find. So that does involve a little bit of problem solving. However, if part A gives you your formula, so if it gives you this equation, you can use that equation for part B. So with optimisation questions, if you have to miss out part A, don't worry about it because the majority of your marks will be in part B. So in part B, it asks us to find the dimension of the case that minimises the use of glass and calculate its minimum area. Now that should seem like quite a familiar statement to you because this is all about your maximums, or in this case your minimums, and that is something that we've been doing a lot in the last few lessons. So we were told that the area of the glass is AX equals x squared over 2000 plus x. So x squared plus 2000 over x. Now from there you're doing the steps that you are familiar with. So we're looking to find the nature of this. We're looking to find out that it's definitely a minimum, and we're then looking to find a value for our minimum area. So the first thing that we're doing is differentiating. So right now that's not in a differentiable format because we have that x on the bottom. So remember, we would rewrite this as x squared plus 2000 x to the negative 1. So you can't have x's in your denominators. You have to move them up and give them negative powers. So if I differentiate this part over here, I get 2x minus 2000 over x squared. Now that is because if I differentiate it, the 2x is fine. When I bring down that negative 1, I get minus 2000, and I decrease my power by 1 to give me that x to the minus 2. Now, as I've said before, the more confident you become with this, the more familiar you become, the easier it'll be for you to skip through some of these steps and see exactly what you're going to. So that's how I've managed to get straight to that step there. Now, it's always nicest to leave or to put your x's back in your denominator to get rid of the negative powers, because remember, your next step is now at SP's a dashed x, in this case, is going to be equal to 0. So we can set 2x minus 2000 over x squared equal to 0. Now, that x in the denominator is back to causing us problems, but this time, rather than moving it up and it becoming a negative power, we are going to multiply everything through by x squared. And that's going to give us something slightly nicer to work with. So we've got 2x cubed, if I multiply that by x squared, minus 2000 equals 0. That means 2x cubed equals 2000. So x cubed must be equal to 1000. So x must be equal to 10. So that's us found our x value. So if we look back to our picture, what we are saying is that our length and our breadth must have a value of 10 to minimise the use of glass. Okay, so because it's asking us about minimising, we need to now prove that that x value is going to give us a minimum turning point. Now, it doesn't matter about our y coordinates for this, so we can skip that one step and we can go straight into our nature table. So remember, we've got 3 rows, x in the top. This time it's going to be a dashed x in the middle, so our derived function. And then we're going to have our slope, and we've got 10 in here. So at 10, our derived function is 0, so our slope is stationary, perfectly horizontal. We're now looking for numbers less than 10 and numbers greater than 10. And remember, you don't have to be specific, you don't have to write them in. So I'm going to go back to my derived function. So I am going to substitute 1 into my derived function over here. So 2 times 1 gives me 2, minus 2000 divided by 1 squared gives me 2000. 2 minus 2000 is going to give me a negative number. Remember, it doesn't matter the value, it just matters that it's going to be negative. So for a negative gradient, that's going to look like that. If I then substitute a number bigger, Now I'm going to go with 20 for this, just because I quite like having my zeros in there. So I'm going to do a little bit working for this one as well. So 2 times by 20 is going to give me 40, and I'm taking away 2,000 over 20 squared. So 2 times 2 gives me 4, and I'm going to have my 2 zeros in it. I can then cancel out my zeros from here. 20 divided by 4 gives me 5. 40 take away 5 gives me 35. Now, it doesn't matter, remember, that I got to 35. It does, however, matter that it's a positive 35. So it looks like this. So that's clearly showing that 10 is giving us a minimum value. So we can then write x equals 10 as a minimum. And the final part of the question asks us to calculate this minimum area. So if we go back to our original function, which is this one up here, and we substitute in 10, so A10 equals 10 squared plus 2,000 divided by 10. So that's going to be 100 plus 200, which is going to give us 300. So our minimum area is 300, and if you look back, the question does mention centimetres, so our minimum area is 300 centimetres squared.